And that chime tells me it's time for us to get started. So we're going to go ahead and get started. It is 4 o'clock here Central Time. Good afternoon. My name is Tim Pope. I'm the Curriculum Director here at Kendall Hunt. And I guess I have to say this is sort of a fun one for us because I wanted to sound like a sportscaster. And we're live from NSTA. We're sitting here in Nashville with our presenter today, Brooke Bourdelat-Parks. Just finished having our first day over at the convention. So we're here for a webinar about the cross-cutting concepts, and without further ado, I'll let Brooke get started. And you want me to talk nice about you, or do you want to do it yourself?
You do it.
Oh. So Brooke, so here we go. I have your title right here. So Brooke, we talked about this earlier today. You've been doing this now for how many years?
Yes, for 9.5 years.
Coming up on 10 years working with these materials, and we're excited with the new edition to have it updated now to incorporate more fully the next generation science standards. Brooke's going to talk today more about the cross-cutting concepts, and then when we're done, we'll talk a bit about the new edition.
Yeah, great. Thanks, Tim. I'm excited to be here today to talk to you about the cross-cutting concepts. This is something that is an NGSS dimension, and it's one of the ones that I think is a little bit harder to be able to figure out how to incorporate into teaching. So I'm really looking forward to sharing some ideas with you today. I did want to start out with a few introductions. If you'll find your chat box, I'd love for you to type your role or your position, what interested you in this webinar. So we'll be able to see that if you can type it into the chat box, and I'll give you just a second to do that. That's great. I'm seeing a museum educator. I'm seeing a high school biology and AP biology teacher. Some people that are assessment specialists and science specialists. Fantastic. Several high school biology teachers. Someone says they're interested in ideas of student involvement and more interaction with NGSS. All right, so y'all can continue typing into the chat box, and I'm going to move along and tell you just a little bit about BSCS and myself. So BSCS does stand for the Biological Sciences Curriculum Study. We're a nonprofit organization that was established in 1958. And at that time, there was an earth sciences curriculum study, a physical sciences curriculum study. And at this point, we're the only ones who are left in our original form. So the same way that Kentucky Fried Chicken pulled the KFC thing so you don't realize it's fried, we usually go by BSCS these days because we do a lot more than just biological sciences. And we do a lot more than just curriculum. We do have a curriculum development division, but we also do a lot of professional development for teachers and educational research and evaluation projects. We're supported by public and private agencies. And BSCS and Kendall Hunt are separate organizations. Kendall Hunt and BSCS have been working together for over 20 years to publish a lot of high-quality materials. But as a result, some of the questions that you asked today will be answered by me, those that are about the work that we're doing in the webinar or about the Human Approach program that I'll be taking examples from. Other questions may be answered by Tim today. So I want to give you a minute to get your brains going about cross-cutting concepts. Without looking it up, I'd like you to take a minute and just jot down any cross-cutting concepts that you know. All right, hopefully that's got you thinking about some of these ideas. So I want to start off with a little story. I have a colleague that used to teach middle school science. She was in 8th grade one day working with her students, and she asked her students to divide. And one of the little boys said, Miss Stinnett, is this the same kind of division that we do in math class? And she said, oh, no, this is very different. First, you have to put this number down. Oh, yeah, that's what we do in math. Well, then you have to make this special symbol. Oh, yeah, we do that in math. That's what we do. And then you put the number that you're dividing by on this side. Miss Stinnett, this is the same kind of division we do in math. Sometimes our students feel the same way about biology. We have these things that we do with energy, and we talk about it in photosynthesis, and we talk about it in food webs. But a lot of times our students don't realize that that's the same energy that we're talking about in both of those areas. So cross-cutting concepts are a way to really help kids think about how these topics apply across a lot of different parts of the discipline, and it helps them engage more deeply and more richly into the content. Cross-cutting concepts aren't a new thing. In fact, in 1993, BSCS published Developing Biological Literacy. And this was the result of the design study that got us started for publishing a human approach. During the design study, we found 6 unifying themes in biology, and they made up the 6 different units of a human approach. In 1996, the National Science Education Standards also listed 6 conceptual themes. 5 of the 6 aligned directly with developing biological literacy, and the one that didn't was behavior, which a human approach included throughout the book. Science for All Americans in 1989 included unifying principles, and Benchmarks for Science Literacy in 1993 also had this idea of themes within biology. So this isn't a new idea to have some sort of big theme or cross-cutting idea that students are expected to know. However, the Next Generation Science Standards are the first time that it's been made an explicit thing that students should learn as one of the 3 dimensions. Luckily, we've got some good support within NGSS to help us know how to do that. And as we go through the webinar, we're going to learn about some of these ways to support you and your students in teaching cross-cutting concepts. I want to start out with a student experience, though, and let you think about what a cross-cutting concept might look like from an activity that you would do in class. Imagine that you had a series of images of hominid skulls, similar to the 2 you see here. Now, students have a table that they're filling out. They put in the fossil name, and then they write descriptions of a number of different traits. What's the size of the forehead for each of the skulls? What does the brow ridge look like? What's the size of the molars? So these are things that students would have an opportunity to look for in all of the different hominid skulls. Following that, they have a chance to read the essay, Primates Show Change Across Time, and then there are a couple of questions for them to discuss with their teams. So what evidence did you find in the essay and in your observations of the skulls that indicates there was a change between early and modern hominids? Now, the evidence, the red, is something that I put for emphasis that we're going to look at in just a minute. Another question the students answer is, what evidence indicates similarities between early and modern hominids? So we're looking at both changes that happened and the similarities that are still there. And then finally, students are asked to summarize the pattern of changes, again, red added by me, that you observe in the hominid skulls. And there's a series of these from Australopithecus afarisans to Homo sapiens. Students then create a poster with their partner about the evidence they've studied. They glue some bones onto a board, they add a summary, and then they use this information to teach their teammates about evidence that physical anthropologists contribute to understanding of how species change over time. So students have actually taken on the role of physical anthropologists. They've gotten to do some of those same things that the anthropologists do by looking at a series of skulls, thinking about what evidence they have that there were changes and similarities, and then thinking about any patterns that they're seeing. They also get to read about an interview with a paleobiologist, and there are some other students that are going through and looking at evidence for that. So all of that took place in Chapter 2. It's pretty early in the year. In Chapter 3, students continue to do some of the same things. They're taking on the role of evolutionary biologists or evolutionary developmental biologists. And now they get to think about DNA. What letters are similar in humans and chimps, humans and gorillas, humans and orangutans? What letters are different among these? What's the percent similarity with the human? That's that looking for a pattern again. So students have now had the opportunity to think about how scientists really work, the type of work they do, and understand that these types of scientists are using patterns. So as we think about this related to the cross-cutting concepts, we have a series of cross-cutting concepts here. I won't make you type it in the box, but can anybody guess which cross-cutting concept I was thinking about when I chose this experience? Hopefully you chose patterns. So patterns is something that we know we can use within all sorts of different parts of biology, within evolution and within other things like genetics. This is another student experience that they're able to have in a later chapter of A Human Approach. Students are presented with two pedigrees. One's a dominant pedigree and one's a recessive pedigree. They draw a two-column table in their notebooks, and then they list patterns that they see in the dominant pedigree and patterns that they see in the recessive pedigree. So now we've looked for patterns within evolution. We're looking at patterns within genetics. So this is an opportunity to make these cross-cutting concepts explicit to students. Many of these things are things that we talk about in class regularly. You've probably talked about structure and function. You've probably talked about systems and system models. But now we have an opportunity with NGSS to go ahead and make sure that students are very explicit and they know what these cross-cutting themes are. So I've showed you a couple of steps from just a couple of activities. Some people feel like cross-cutting concepts are going to cause a major change. They'll only be able to do this if they make wholesale changes to their class. But I want to convince you that that's not the case. So as we think about stability and change, in NGSS Volume 2, you can find a description of this in Appendix G. So one of the things that they say about stability and change is that for both design and natural systems, conditions that affect stability and factors that control rates of change are critical elements to consider and understand. So we need to understand what causes things to stay the same, what causes things to change. Now, NGSS goes a step further in helping to support us in teaching these cross-cutting concepts. They have, for grades 9 through 12, a series of 4 different elements that students are expected to know related to stability and change. I find that stability and change is one of the things that we tend to talk about but aren't very explicit about. So I wanted to choose it as another example to help you see what we can do with this. So here's one of the elements that they have. We're thinking about constructing an explanation of how things change and how they stay the same. That's pretty explicit. Once I read that, I feel like that's something that I might be able to do in class. It's much less vague than, oh, talk about stability and change. Another element is we can quantify these rates of change. We can model these rates of change, and we can see that they happen over short periods of time or long periods of time. Sometimes these changes are irreversible. And finally, feedback can stabilize or destabilize a system. So with each of these, oh, there's one more, sorry. Systems can be designed for greater or lesser stability. So for each of these four, this is giving me some more specific guidance about what students in 9th through 12th grade should be able to do related to the cross-cutting concepts. For me, this really made me feel better when I realized that I could look at these elements and I could think of specific examples of how I would do this with my class. So as I think about topics involving stability and change, we've got evolution. There's a lot of stability and change in evolution as we think about the things that have stayed the same across time and the things that have changed across time. Homeostasis. We know that we want to maintain some stability in our body. So when changes happen, how do we get back to that stability? The central dogma. We know DNA to RNA to protein. That's drilled into our minds as biologists. But we also know when there's a mutation in that DNA, that has consequences as you go downstream, and it can lead to lots of different proteins. Ecosystems. You introduce an invasive species. Well, what happens? There are things that change in the ecosystem. So let's imagine I want to think about a lesson with ecosystems. I'm thinking about stability and change. And now I want to know how I can really help my students understand this cross-cutting concept. I think that this particular bullet about modeling changes over a short period of time, long periods of time, and some being irreversible might be the way to go. So let's look at another example from a human approach. I don't expect you to read this, but this is a letter that the students received from Chris Tackle, president of the Tri-Lakes Association. Chris has written to the students because they're concerned about a problem that they're having in the region. There's a lot of fishing going on. People fish for a lot of bass, but there aren't as many bass as there were a few years ago. And so as a result, they're kind of losing all of their tourism because the bass fishing isn't known to be as good. Now, Chris knows that the biology classes at Tri-Lakes have kept a lot of information about the water quality in the lakes in the last few years. So the members of the Tri-Lakes Association are really hoping that the students can help them figure out what's going on. They've got a little bit of information that they provide. Small invertebrate animals such as Daphnia and Gammarus are less common in the lake than they used to be. The lake is a lot greener for more of the year than it used to be. And both the bass and the perch are smaller, and the perch are a lot less colorful than they were previously. So the students are given this information, and they're also given a packet of information to try to help them figure out what's going on. So as we think about stability and change, there are definitely some changes going on here. In the student experience, the students get to read evidence to determine what's happening in the system. You can see here on the right that there are several different types of things that they receive: an advertisement, some different articles about the Tri-Lakes area, information about some of the species, not only the bass and the perch, but also the Daphnia, some algae, some cyanobacteria. They get some quantities about the total number of species caught annually, the number of largemouth bass and perch caught annually, And then they also get information about acid precipitation. So as students go through the activity, they get to figure out which pieces of evidence they think are going to help them figure out what's going on in the lakes. They get to quantify those changes, the total number of fish. They model what's happening in the system through a wet lab. They use Daphnia and Gammarus with the pH, changing pH, and see what happens to these organisms. And finally, the whole activity allows them to see that species can go extinct, and that makes an irreversible change. So in this opportunity, students get to explore how stability and change affect a real-world situation. It's not just, hey kids, let's learn about stability and change. Here's positive feedback, here's negative feedback. What do you think is going to happen? They're really looking at a lake ecosystem and seeing what's happening to all the different organisms and why they think that's happening. So they're developing specific skills related to that cross-cutting concept that I picked out. Change and rates of change can be quantified and modeled over very short or very long periods of time. Some system changes are irreversible. So I'd like to give you a chance to think just a little bit more about this. As you think about this cross-cutting concept of stability and change, type a few things in the chat box about other topics that you might use as this is the basis for as you're studying. Where else in the biology class do you see stability and change playing a role? So go ahead and type your ideas in the chat box. Be as specific as you can.
So is this webinar wait time?
This is webinar wait time. Getting some good ideas here. Climate change, sea level rise, cells and solutions, that's a good one. The aging of organisms, the immune system. The immune system is definitely a place where stability and change has a big role. So you see, all of these are places that we can use the cross-cutting concepts. But the idea now is that we want to really support our students in learning about them. We want it to be something where it's explicit to them and they know that this idea goes throughout the discipline of biology. So thinking about the Tri-Lakes experience, what other cross-cutting concepts could you address? You've got your cheat sheet over here on the right. So what else could be part of this experience? As you think about your list, I'd like you to sort them into what you would want in the foreground and what you would want in the background. So go ahead, if you type an idea into the chat box, what's something besides the stability and change that you could use this experience for? Systems, that's a great one. We've got this whole system with lots of interacting parts, and when something happens to one of the parts, it changes a lot of the other parts. Cause and effect, that's another great one. You may have noticed we were talking about pH and acid precipitation. Students have an opportunity to see how those are, the pH of the lake is changing, and that's really affecting the organisms. Energy and matter, that's another one. As we think about what the fish eat and what types of things are going on as interactions between the different organisms, we're getting energy. And if you can't get the energy and matter that you need, you can't grow. So this is something that we can see how the cross-cutting concepts play out in a lot of different ways. But I asked you to think about the foregrounding and backgrounding, because if you were to tell students, oh, all of these apply to everything, that kind of gets them a little jaded and they don't really understand how things are playing out. So this particular teacher, you can see this isn't a great picture, but I wanted to give you an idea of what she did. This is the ceiling of her room. And around the top of her classroom, she had 7 posters, each one with one of the cross-cutting concepts. And so she was able to point out to students when she did a particular cross-cutting concept and had students think about, how did this activity relate to this? Now, 1 or 2 is great. That really helps students see how this activity related to each of these cross-cutting concepts. But if you start pointing to all of them, they really do get confused. So we need to scaffold student understanding about these. I've put some questions here. They're showing fading scaffolding of the cross-cutting concepts. So at the beginning of the year, you might say, our activity helped us look at patterns. Where did you look for patterns in the activity? This is just helping students understand where they were looking for patterns, what a pattern is. That helps them understand what they'll be looking for later in the year. A little while into the class, if a month or 2 in, you might say, our activity involved looking at patterns. How did looking for the patterns help you understand more? So now students get to think about, okay, I used this cross-cutting concept of patterns. I looked for patterns, but what did that tell me that I wouldn't have seen had I not been looking for the patterns? Still later in the year, you might say, our activity used patterns to help us find information. Were there any other cross-cutting concepts that you used, and how? Now, this is helping students understand that these cross-cutting concepts are things that we use a lot, and maybe patterns were foregrounded in this particular activity, but they have a chance to apply what they've learned about the other cross-cutting concepts and say, ooh, I know that we were also using energy and matter here. And then toward the end of the year, once students have had experience with all 7 cross-cutting concepts, you might say, what cross-cutting concepts did we use in this activity? Explain your choices. So now students have an opportunity to pick the things that they think were foregrounded, explain what they were and how they related to the activity. So in this way, not only are you relating the activities that you're doing to something important, a science idea, but students are getting to explain what the connection is there. And as they see that patterns play out in evolution, in homeostasis, in genetics, in ecosystems, they start to develop those habits of mind. So now whenever they see new information, they may think, ooh, I wonder if there's a pattern that I can tell. That may help me learn more information about this. So we know that students rarely have the ability to understand what the cross-cutting concepts mean from the very beginning of class. A lot of these are words they've heard: change, energy, matter. But to think about how those relate to each of the different areas you might study in a biology class is not something that students have necessarily done. So that's why it's important to start the year with questions like, this is a cross-cutting concept that we used. How did we use this concept? We also know that they need to develop their skills in using and understanding them. So if you can provide that fading scaffolding as the year goes along, they begin to really get a feel for what patterns look like in homeostasis, what kind of patterns they might look for in genetics, And that gives them the flexibility of mind to be able to see patterns in lots of different types of information. This means that it's really important to make your cross-cutting concepts explicit and scaffold their learning. So the same way the teacher that I showed the picture from her room had all of the cross-cutting concepts around her room, she was able to make them explicit. Anytime they did an activity that related to one of the cross-cutting concepts, she was able to stop and physically point and say, this is the cross-cutting concept we were looking at here. And finally, working with just one or two of these in the foreground is really a way to help students develop the habits of mind to use them. Because you're being explicit, because you're giving them specific questions and things to do with the cross-cutting concepts, now they really start to understand this is the type of thing I need to do anytime I'm approached with a new science topic. So as the teacher, what does this all mean for you? I want to emphasize you don't have to plan the whole year. This does not have to be a wholesale change where you take the next week to sit down and plan out every cross-cutting concept for the rest of the year. Just take a moment before each lesson to see if there are cross-cutting concepts that would really be helpful to students to understand what you're doing in class that day. You know, you were able to very quickly come up with some of the other cross-cutting concepts that were part of Tri-Lakes without even seeing the whole activity. So this is something that comes naturally to us. But by thinking about it before class, it helps us have it in our minds of, oh, when we get to patterns, I want to make sure I point that out. And then think about how you can make the cross-cutting concept explicit. Maybe it is pointing it out on signs in the room, but maybe it's asking a particular question of students. How did these patterns help you see something? Where were you looking at stability and change in this activity? And then finally, keep a record for yourself of which cross-cutting concept, which element, and how you help students on a particular day. So for example, you may have a record like this one where you keep track of the cross-cutting concept and the element. Maybe on September 3rd, you provided specific information. You said, we are looking at energy and matter today. But maybe on September 4th, you asked students to consider how this helped them with their learning. And then on September 8th, you both provided some information about one and asked about other cross-cutting concepts. Now, this isn't meant to be a huge task of you have to very explicitly keep this record so that you know exactly what you're doing, but more, it gives you a snapshot. As I look at this particular table, this is only 3 elements from one cross-cutting concept, but I can clearly see that I've only asked about other cross-cutting concepts once. So as your table fills out through the course of the year, you can start to get a feel for, wow, I haven't really done much with the 6th cross-cutting concept. Or I've given students a lot of specific information, but I haven't really asked them about other cross-cutting concepts lately. So by having this filled in each day, you can at a glance figure out where you might need to focus some of your lessons. Now, when I talk about elements, I want to make it clear that these are from NGSS. This is Appendix G. If you just do an internet search for NGSS Appendix G, it'll come up. And this includes the elements for each cross-cutting concept. Conveniently, it's divided into each of the different grade bands, and there are specific elements that help us know what students should be able to achieve at that grade band. So this really gives us a clearer picture of what it looks like to use the cross-cutting concepts. I love this response that Kevin gave us. He was saying that it could be part of an ongoing reflection that the teacher would be doing on how lessons go and how they'd improve them the next time. It wouldn't have to be a new and separate thing, but just as you're taking notes for the day, you add it into your table of, we were doing this cross-cutting concept and this is how we did it. So that would be a great way to just incorporate it into your daily reflection. So to conclude what we've been saying about cross-cutting concepts, you want to be purposeful about what you want students to learn in a given experience. Just because you can incorporate all of the cross-cutting concepts doesn't mean that's what you want to share with students. Pick one or two that really lend themselves well and focus on those so students learn how to do them. Consider where your students are in learning about the cross-cutting concepts. From the beginning, you're not going to be able to throw a list up on the wall and say, hey, how did you use any of these today? Because students won't know what those words mean. In fact, a lot of our students who aren't very comfortable with science really feel like, oh my gosh, big words, stability, change, energy, matter, I don't know what those are, so I'm no good at science. But if you do work to scaffold it and help them understand what that means, think of how powerful that is at the end of the year when you can give them an activity and say, which cross-cutting concepts did you use? And that student who's maybe never liked science before says, I know that I used energy and matter. I know that I was looking for patterns, and I know that there's a role for stability and change. That would be such an amazing thing to have a student do. So finally, be explicit with the students about the cross-cutting concepts so they really develop the habits of mind. We want them to start realizing that they can get deeper into content, they can understand it more richly, and when they're approached with new content, they know how to think about it from using these cross-cutting concepts as their point of view. So I want to thank you for your attention today. I'll be here to take a few questions, but I think Tim wants to say a few words before we get to the questions. So I'll turn it back over to him.
Shuffle, shuffle. Thank you. That was great. It's incredibly timely to be doing it as well. I was saying just yesterday I had the chance to be at the Science Leaders Day, the Ancella Group's Day, and the entire day was built on this: how do we help teachers and students understand the three dimensions and how those come together for instruction. So I'm going to try to reasonably quickly go back because I want to show you how we've made that look in our book, in the new edition of A Human Approach. If I can get to it relatively quickly. Not used to both of us using the same computer. I can't be quite as quick on the draw. And I need to do a screen. I'm gonna move this over here. Give me just a second. I'm trying to pop up the new book, and that should work now. So I want to show you a couple things from the new edition, specifically about how the BSCS group has worked to incorporate. Now I gotta wait for it to load. But how they work to incorporate the three dimensions into the book, and how to help teachers integrate those more clearly. So here we have, and it's not gonna let me get bigger. But you can see here, so there's a table now with each chapter, where as the science and engineering practices, along with the core ideas and the cross-cutting concepts, so the authoring group really has worked to help you make that content, how to make those connections that you were just talking about in your webinar. So the new edition just came out, hot off the presses, and I want to show you then how to take a look at it. If you'd like to have a demo, there's a couple ways to do it. One is to go to flourishkh.com like that, and just click on Preview Now and answer a couple questions, and we will set you up. Right now, we just have we have one demo chapter of the ebook ready to go. The rest of the book will be loaded, I'm told, by next week. That was the happy news I got yesterday. And then you're also going to be getting an email in the next day or two from your local curriculum consultant. And if you want a print copy of the book or want access to the full book, just reply to that email and let them know, and we'd be happy to set you up with whatever you might need to fully review the program. So with that, I'm going to look real quick and make sure I didn't miss any questions. Let's see here. And I'm assuming Angie would tell me if I was missing one. Here we go. I don't see any questions. So with that, I'm going to thank Brooke for taking the time and being willing to sneak over to the hotel from the conference to do the webinar.
Absolutely.
There we go. And thank all of you for attending. And we'll be in touch soon to follow up to get you a preview copy of the book. So thank you and have a good evening.